So this is Unit 6, Lesson 2, Inheritance and overriding, actually not overloading, overriding. So we talked about in the last lesson, when you have a child class, it has all the methods that are in the parent class. Well, suppose the child class does not function well with the exact same methods as the parents. For example, our children's book had an illustrator, and our two-string class in the book class did not print out the illustrator. So we would probably want to change that to make it so it would also print out the illustrator. This process where we change the method is called overriding, where the child changes the method that belongs to the parent. Now you can override any method but the constructor for a very simple reason. All classes need their own constructor. So the child method has to have its own constructor because it has to match the name of the child class. So you can't override the book constructor. You would create a new constructor for the child book and maybe use the super command to address and add in any changes you need for the child class, children's book. But any other methods, like the two-string method, or add title, or add author, or add year, we can go ahead and override and make them into something different. So let's take a look at this class called quadrilateral. It has 4 pieces of data, side 1, 2, 3, 4. It's public, quadrilateral, side A, B, C, D. Really simple, straightforward constructor there. And then we get its perimeter, side 1 plus side 2 plus side 3 plus side 4. Very straightforward quadrilateral shape there. So suppose we wanted to write a class called rectangle that extends quadrilateral. Let's think about that for a couple minutes. Pause the video. Think about what structure, what things would you have to change. So pause the video and do that. So if we look at the quadrilateral, we see that the major difference in a quadrilateral is that side 1, 2, 3, and 4 could all be different, whereas in a rectangle, 2 of the sides sets have to be the same. So we're going to definitely want to handle that. So one way of doing that would be to build our constructor. So it takes 2 parameters, 2 integers, and then call the super, which goes back to the quadrilateral class, calls that constructor, and sends it A, B, A, B. So that lines up our side 1 with side 3, and our side 2 with side 4. So that's handled for us neatly. Then if we wanted to print out the perimeter and do our values, we would get, in our public static void main, we have our quadrilateral Q, make it a new quadrilateral, 3, 7, 6, 7. Print out its perimeter. That works out nice. It has a get perimeter method, and then the rectangle has a get perimeter method, even though we didn't write one. Rectangle has a get perimeter method, even though we didn't write one. Why? Because it's back here in quadrilateral. It's calling back to this method. Remember the way the chain works. If the method doesn't exist in the child class, Java automatically goes back up a level to the next closest relative, the parent class. If it's not in that parent, it would keep going up until it found it. If it didn't find it, then it would throw an error. So we now have a nice functioning little shape here. We got quadrilateral and we have rectangle. But suppose we didn't like the way perimeter works. Suppose instead we wanted to change the perimeter so that it did something like twice side 1 plus twice side 2. We could override that method and just write a new one. So this new method called getPerimeter, I know I have it crossed out, but there's a reason. We're going to get to that in a minute. Return side, getPerimeter, return 2 times side times 2 times side 2. So I have this crossed out for a very good reason. There's a problem here. I'm going to pause the video, and I want you to think about what is the issue here. The issue becomes that side 1 and side 2 are private pieces of data that live in quadrilateral, so the child class doesn't have it. So what we really need is we need to have had an accessor method added in the quadrilateral. So this method has to be in quadrilateral. And then we're going to do this, we're going to use something, a new structure called a switch statement. So I'm going to explain this in a minute. So just hold off. Let's assume for a second there's some way of getting, based upon which side we want, the value of that side. Let's assume that method works properly. We could have done it with if statements. Imagine you wrote it with if statements instead of this switch statement, which we're going to talk about in a minute. And then we could then get access to the perimeter by either doing 2 times the super dot get side 1, 2 times the super dot get side 2. But since rectangle doesn't have a get side method, it would automatically go to the parent method, so we don't really need to say super. We could just say get side 1, get side 2. So the rectangle would say, oh, I don't have that method. Let me go look to see if there's a public method I have access to in the parent class. And it would go up and look to see if it had access to that, and it does. So it could just use that. So now it has access to the values of the individual sides. Data is always going to be private in terms of style. Java doesn't care if you make it all public. People would say, well, the simple solution is just make it all public. Well, the problem with that is you give everybody access to it at that point. Not just to children, everybody gets it. So you want to build accessor methods. There is a way to create a private set of data that gives access to multiple classes to that private set of data. That's a different type of structure. It's called inner classes, but we're not going to talk about that right now. Okay? We might mention it briefly later, but we're really not going to dive too much into it. So there is a way, but we're not going to do it right now. So let's deal with this thing here, this switch statement. This looks rather interesting. So what's a switch statement? Well, it's a filter. And a lot of people say, wait, it says switch. It sounds like it should just be a switch. No, it's a filter. And you need to think about a switch statement as a filter for a very simple reason. It checks every case. All the time. So, for example, if someone types in a 1, it checks to see, is it case 1? Yeah, then it returns side 1. But the return statement is what kicks it out of the method call. That's what's kicking it out. If there was not a return statement here, if it was just, let's say, a print statement, say case 1, let's see, switch S case 1 system.out.println 1. Okay? It would then automatically drop down to case 2. Even though case 1 already was evaluated and did something. Every case that's true gets evaluated unless there's something that breaks it out of the switch. There are 2 ways to break out of a switch. One is with a return statement. Return statements return control to the calling function or method. Sends you back to where it originally linked. Ignores the rest of the code. Returns like the eject button. Ejects you out of the method. Break would eject you out of the switch statement and not of the method. So sometimes you might want to just run the switch statement and not jump out of the method right away. Maybe there's other stuff that you need to accomplish. Break will drop you out of the switch statement without filtering through and checking every single value. Now the reason I mention this is because a lot of times people end up using these things in methods and use the return statement and then never realize that the case statement is a filter. It runs through every single case. And if it fits through that case, then it gets through. Imagine when you go to like the Coinstar place at the supermarket, when you dump your coins in. Pennies go through the quarter slot. They go through the nickel slot. But then they stop at the penny slot because they won't fit any further. That's how it works. So it gets tested against the quarter slot and say, yeah, okay, it passed that. It passes through that. It gets tested against the nickel slot. Yep, it passed through that. It gets tested against the penny slot. Nope, it doesn't pass through that. And it goes on. Worse yet, Java would keep checking and say, oh, look, let's look at the next one. Let's see what happens after that. So this will all the way filter through the case statement no matter what, unless you break out of it, using either a return statement to kick you out of the method, to eject you out of the method, or a break statement to eject you out of the switch statement. So those are the two ways to get out, either a return or a break. The other thing down here is a little weird, is the default. You don't have to have a default value, but when you're dealing with methods, you really want a default value. Because otherwise, Java will say, well, technically, if somebody types in something other than a 1, 2, 3, or 4, then we're not going to return anything. There's no return path. So you have to put that default there, especially when you're using it inside of a method to eject out of it. So Java has some way of returning something. It always has to have that ability to return a value if it's expecting to return a value. So if we didn't have this here and we ran it, we would get an error saying there's no return path. Something's missing. So the other way of dealing, like I said, with the breakthrough instead of the return statement is the break statement. So this is what it would look like. Let's say you had a case 5. You could print out hi, 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 and then you would put this command here called break, and that would keep it from going on to the next case. It would jump out of the switch statement and be done. If you don't have the break, it will continue on to the next case. And case statements don't just have to be case 1, 2, 3, 4. They could be inequalities. That becomes really useful. You know, is it greater than 7? Is it greater than 8? It's kind of like playing 20 questions. Is it bigger than a bread box? It filters down and tests every single thing because more than one of them could be true. This is not multiple choice, it's multiple select. More than one of them could be true. So that's when you use the switch statement, when there's a possibility that more than one of them can be true. But switch statements have essentially replaced simple if-then-else statements because if-then-else statements are really complex and get really ugly. So if you're only testing one thing, switch statements become much more convenient to write and become a lot cleaner in code and easier to understand rather than trying to figure out the if-then-else structure. This is just makes more sense. So that's why we have, the other reason why we have the structure, and a lot of people use it for that, replacing if-then-else statements. So here's the general structure for a switch statement. You have the command switch. You have the expression that's going to be compared against each case. So this is some type of variable. Case, and then some constant. And then the statements, and then the break. If you don't have the break, it will automatically filter down to the next one, whether this was true or false. It doesn't matter. Whether it was true or false, it would just keep moving down. The break statement kicks it out when it's true. Case 2, statements break. Default statement for when it doesn't match anything else. You don't have to have a default statement, but it is good practice, especially when you're dealing with method returns. Then it becomes critical because there won't be a return path. If you're not dealing with method returns, then it'll just fall out the bottom and nothing will happen. So here is an example in practice. Suppose we have something called commission rate, and there's some variable called sales class that is determining what their commission rate is. They're either a class 1, 2, or 3 person, otherwise they get the default commission rate. So if they're a class 1 person, in other words, if sales class, the variable, equals 1, then we would execute case 1. So they would get a commission rate of 0.02. And then we break, so we don't need to check the other ones. Could we check the other ones? Sure. Java will go through and check all of them and try to match. Does sales class match the case? That's kind of silly to not put the breaks in at that point because you're wasting extra comparisons. You don't need that. Sometimes you do. Sometimes it'll match more than one case. Case 2, commission rate. That means sales class equals 2. Commission rate gets set to that, and then we break. If it didn't work, then we would look at sales class 3. Compare 3, the number 3, to sales class. If it's true, commission rate gets set to that, and we jump out. If none of these are right, there's no match, it goes to the default, and then the commission rate is 0, and then we jump out. So typically, the default ends up being your error checking for your users. If they enter in a value that is something else, maybe we do a little bit more than just, maybe later on we check to see if the commission rate is less than 0, then we print out some error checking, we catch that as an error, put it to the screen and say, hey, silly, you were supposed to type in a 1, 2, or 3. Can't you read directions? No wonder you're getting a 0 commission. Okay, something nice like that. Be nice to the users. Be nice to your users. Don't make them feel small. So, the key to understanding this is that you don't have to code in any cases for the A group. In other words, suppose we decided for sales category to use characters. Let's follow how this flows. Case capital A. It matches. Do nothing. But there's not a break. Case lowercase a, the commission rate gets 0.02. Break. So the case A group doesn't contain any statements, but falls through to the case lowercase a group. So even though this matches, it doesn't break out. Case B, no statements. Don't do anything. Then, case lowercase b. This is the commission break. So there's a pass-through here. There's no break. Even if it matched, let's say we did an uppercase, or a 2 lowercase, right? Somewhere in here. And forced it. It didn't matter. It doesn't matter which one it is. If it matched it, or if it didn't, it would move on. So maybe instead of doing case capital A and doing no statements there, we would do case capital A and then do sales category equals sales category 2 lowercase. And force it to lowercase, but not break. That way it would filter down to the next level and carry that out. So the main thing to understanding this, the key to this that I'm trying to show you here is that this case statement here, even though it might be true, doesn't have any statements, so it filters down to this anyway. And does both. It checks both. If it's true, then it breaks out. Otherwise, it filters to here, case B. And then doesn't do anything, even if it is case B, and moves through and checks the next one. So you can use this as a sieve. You can sort out your data and have multiple things be true. We can also use strings inside of the case statement. And it's using a string literal, so we don't have to use the dot equal sign. Because it's a string literal, it's okay, it'll compare it. If it wasn't a string literal, then we'd have a problem here. But since we're comparing string literals, we're just going to say case category A, case category B, case category C, default commission rate 0. Clearly spelling would count in this case. Pardon the pun. So you can compare strings. So that's pretty useful. So, back to the class. Why would you want to use the super method, though? Once we've built our getSide, we have the option to say super.getSide or getSide. Why would you want to do that? Well, super lets you directly call the parent function instead of calling the local child function. In this case, it doesn't matter. But suppose we wanted to use getPerimeter instead, or some other method that we also had in the child class. In other words, if we overrode some method that existed in the parent class, there are now two versions of that method, the child version and the parent version. If I want to specifically address the parent version, I would have to use the super modifier so the parent is called specifically. If I don't use a super modifier, then Java uses the closest method in the hierarchy. In this case, it doesn't matter because getSide exists in quadrilateral. It doesn't exist inside, well, it does, but it's inherited by rectangle, passed down. So, I think this was a sick joke. Somebody decided, let's pick two concepts that are slightly related and name them almost the same thing. Overriding and overloading. This drives me nuts that they chose these two names, because they just could be very confusing when you're first trying to learn, which means you just got to sit down and memorize it. Overriding means you're replacing. You're overriding it. Overloading, think about it as a cart. You're carrying more stuff. Where do you carry stuff? It's in the parameters. That's where you carry stuff along. So when you're overloading, you're carrying stuff with you in the cart. That's your parameters. When you're overriding, you're replacing. We're writing a new method to replace another method. So that's the best I got for you in terms of remembering them in a mnemonic. So typically, overloading really always occurs in the same class. You overload constructors. So you have multiple constructors, or maybe you have multiple methods of the same name, all with different signatures. But you technically could overload inside a child class, sort of. If you wrote a method that had a different signature than the parent, that's not really overriding anymore, that's overloading, because you're writing a new method with a different signature. So Java is looking for the method with that name, with that signature, and finds it in the child class. So that's technically overloading. I can't imagine the AP exam getting that particular about it. I guess they could. But overloading is any time you're dealing with the signature, changing signatures. Overriding is the parent class, and it can use the same signature. So the only way to override is having a child-parent relationship. You can't override within a single class. That doesn't work. That absolutely won't work. You can't have two methods of the same name and the same signature with two different things. It doesn't work. The only way to do that is have a parent-child relationship. It's the only way to override that. So as a challenge, what I'd like you to do is take a look at this if-then-else statement and rewrite it as a switch case block. Pause the video, give that a try. You can do it just on a piece of paper, see how it works. So pause the video. Well, here's the solution. We set up a string just like we had before. This is exactly the same. That should not be a smiley face. It should be a parentheses there. And then we have switch case face, which is comparing face to 1, then face to 11, then face to 12, then face to 13. And we're going to set the face to ace, jack, king, queen. Don't forget your break in between each one of them. The default case would be no. And then we're going to do plus face. And then we're just going to return the suit just like we did before. So that's rewriting that. There is an assignment and an exit ticket. Work on that, and I'll see you next time. Never stop coding.